Okay, now still got our question, but here we're going to show that the limits actually equal what they show. Let's skip A first. We'll come back to A. I want to do this one first because this one actually has like a rule that we have to do that you're probably more familiar with. That rule is going to be f of x equals 3x plus 1. Okay, so this is saying what is the limit of this guy when x is approaching 4? Okay, so let's do this. Now, one way to show this is to show that how do I say this? Okay, it's given us the limit already. The limit is 13. Now, let's graph this and kind of get a visual on this. If I graph this, oops, no, let's put it down here. You guys know how to graph 3x plus 1. You get the 1 is the y-intercept. You go up 3 right 1, up 3 right 1, and then we have a line right here. Okay. Now you guys can see that line and you can say, yeah, that's not going to have a hole in it. I recognize that line. I've seen that line before. It doesn't. It doesn't have a hole in it. So what you can actually do is you could plug in 4 and see if you would get 13. But that doesn't always work. In this case, if we did plug in 4, it would be 3 times 4 plus 1. So you would get 13, right? And so it appears that if we're looking for the limit as x approaches 4, that it will be 13. But how do we show that? You show that by doing this. Taking whatever the limit is, or whatever the value is, and subtracting 13 from it. So you would take f of x, whatever f of x is, and subtract 13 from it. And if this number is really close to 0, if it continues to get closer and closer to 0, I'm sorry, 0, then 13 is actually our limit. So again, this is confusing. Let's plug in some numbers. Here we go. Let's do what we did before. So we're approaching 4, right? Now coming from the left-hand side, give me a number that's really close to 4. 3.9. Okay. So we're going to find the difference between those two, and then we're also going to find the difference between 3.99, f of 3.99 minus 13, and then f of 3.999, and then we're going to minus 13. Because if this number is getting closer and closer to 0, then 13 is the limit. It's correct.
Yeah, but how do you know how many to do?
You only have to do 3. I would do 3, but you can continue to do this forever. You're just trying to find a trend. You're going to see if it converges to that point. Yes?
Why did you...
Maybe I should have written this. Sorry. Prove. So we're proving that this limit actually equals 13. And so if I find these right here, I can see if the difference between those two gets closer and closer to 0. So negative 0.3. Okay, so you got negative 0.3, right?
Yeah.
Minus 13.
Oh,
you already did the subtraction. Oh, okay, cool. So can you tell me what you got for f of 3.9 first, so I can write it down? Is it 12.3? 11.7? 11.7, and you're subtracting 13, and you got...
It's 12.7. Just kidding, 12.7.
Yeah, 12.7. That's what I thought. Okay, and then you get 0.3, right? Actually, it's negative, right? Okay, and then what about this one right here? Who had that one? 12.97. 12.97? And you subtract 13, what'd you get? Okay, is this getting closer to 0? Okay, what'd you get, Adrian, for the last one?
I got 12.997.
And we subtract 13 from it.
And then the same thing as that, but with another 0.
That's it?
Yeah.
So, you guys see these numbers right here? The differences are getting closer and closer to 0, so therefore, we know that 13 is, it's got to be the limit. Okay, but we also have to check it from the other side. Oh man, you guys see how like we're approaching 4 right here from both sides. We're approaching it from this side, and we got to approach it from this side to see if the limit actually is 13. Yeah, we're proving it. So then we would go 4.1, 4.01, and then 4.001. Okay, and it gets kind of annoying. Okay, we can actually simplify this a little bit. So let's go back to this guy right here. Let's see if we can simplify this. F of x equals 3x plus 1. So what I just did is I took out the f of x and I put in 3x plus 1. I want to see if I can simplify this. And actually, the way the book does it, just so if you guys go back and read it, the book takes the absolute value of these, which doesn't really change much, just kind of like makes everything positive. So you can, those are positive, those are positive. Just in case if you go back and read it and need some extra clarification. So I'm going to take the absolute value of this too. And so what we're going to do here is we're going to simplify this. This is going to be 3x plus 1, and we're going to subtract 13 from it. Then we go 1 minus 13, so we have 3x minus 12. From that, we can factor out a 3, and so now we have 3 times x minus 4. And this guy right here is all you need to get these numbers. You can plug in 3.9 to this x, and you will get 0.3. You could plug in 3.99 into this x, and you'll get 0.03. You guys see that? You can plug this into the x, and you'll get 0.003. And so that's how you would simplify it. And this is just a way to show that this limit actually is that limit. It's annoying, it's tedious, and it's not something that you have to always do. We're just doing it to try to help us understand what a limit is. Now we did it for coming from the left side. You should also do it coming from the right side. I'm just going to write the x values down. I'm not going to do it all. And so the x values that you're going to plug in is going to be 4.1, 4.01, and 4.001. And when you do that, this number, these numbers right here, should be approaching 13. And they do. Okay, the limit of 5 as x approaches 7. Now 5 is the function. If you just had f of x equals 5, do you guys know what that graph would look like?
Horizontal line.
Yeah, it's a horizontal line. And so if I draw my my graph right here, I could go 1, 2, 3, 4, 5, and I would draw a horizontal line right there. That's the graph of that right there. And so what would that equal? If as x approaches 7, what would f of x be approaching? 5, right? That kind of makes sense, right? It's just kind of common sense. And from that we get a law with limits. If you have a limit and it approaches c, and this is just a number. Let's see. Let's use a. That's always going to equal a. Like in other words, if there's no x inside of our rule, then we know it's going to be a horizontal line. And so it's just going to equal whatever you have. It doesn't matter what the limit is approaching, it's still going to be a. So in this case, it's approaching 7, but it doesn't matter, it's still going to be a, which is 5. Does that make sense? There's another one. And let me give myself some more room. This one is as the limit approaches c. As the limit approaches c of x, as the limit of x approaches c, then you're going to get c. Now this makes sense if we actually graph x. You guys know what x looks like? If I actually graph x, then it's going to be this, right? 1 is going to equal 1, and 2 is going to equal 2, and 3 is going to equal 3. And so at every point, it's just going to equal the same thing. So if I'm saying if I'm approaching 3, then f of x is also going to approach 3. That's what this is saying right here. Does that make sense to you guys? Yeah. All right. And we'll explore these more and more as we get into the problems that actually involve them.